We meet the NASA scientists who repaired a spacecraft from 15 billion miles away. The Voyager One is known for being the first spacecraft to go beyond our solar system. So when it stopped sending data back to Earth last November, the team faced a daunting task. They traced the problem to a single malfunctioning computer chip and announced yesterday that they finally made contact again.
It's no news that Voyager One is one of mankind's wonders. It is also a mystery how much it has been able to reveal about outer space and everything that exists beyond our planet. The information it has provided about the other existing planets over the years.
They tried sending it code to get communications working again. That approach worked. The next step is to get Voyager to send science data again.
Have revealed a lot of information about all that exists beyond us. It is no wonder that it made the news when Voyager One captured proof of a foreign and terrifying signal after 46 years of its existence. What could this mean for what we know about outer space, and have scientists found out why this happened? Join us as we share everything about the terrifying discovery Voyager One has made. The terrifying signal. For nearly 50 years, Voyager One has traveled farther than any spacecraft in history, sending back information about space. But now, something strange has happened.
The most important reason for sending the thing out there is to get the science data back. And so the instruments are taking visible pictures, infrared pictures, measuring particles in the case of Voyager. We need to get that data back down and distribute it to the scientists.
Scientists have picked up a mysterious signal from Voyager One, over 15 billion miles away. This signal, described as a faint and unexplainable pulse, feels like a whisper coming from the edge of the universe, and no one knows what it means. Voyager One was launched in 1977 to explore the outer planets and has since moved beyond our solar system, entering interstellar space.
NASA confirmed Thursday that the Voyager One probe has made history by becoming the first human-made object to leave our solar system and interstellar space.
For decades, it has sent back data about this distant region, but this new signal is completely unexpected. It raises exciting and unsettling questions. Is it caused by something unknown in space, or is Voyager One itself showing signs of trouble after working for so long? This discovery is important because it's so unusual. Space is mostly silent, so when something like this happens, it gets everyone's attention. Wait till you find out the main reason why. The signal was noticed during regular checks of Voyager One's transmissions. At first, it didn't seem like the usual data. It was faint and irregular but seemed to follow a pattern. But it wasn't just random noise or a simple glitch. Engineers thought it might be a problem with Voyager One's old instruments, and since the spacecraft has been working for decades in extreme conditions, it wouldn't be surprising if something broke down. But after careful checks, no errors were found in the equipment. The signal continued, confusing everyone. Some scientists believe the signal might be caused by something in interstellar space, like strange activity from cosmic rays or interactions with charged particles. Voyager One has detected plasma waves in the past.
March of 2012, it turns out there was a massive eruption from the sun which eventually reached Voyager One in April of 2013. When that blast wave reached Voyager, it caused the plasma around Voyager to vibrate or oscillate in a certain particular tone.
But this signal was different. Other speculations say it could be something unusual, like signals bent or magnified by gravity from massive objects like stars or black holes. While this idea sounds unlikely, space is full of surprises, and we still don't know everything about it. There's also a chance the signal is coming from Voyager One itself. After 46 years, its systems are old and wearing out. This could be a sign that the spacecraft is struggling to keep working. No one knows for sure what's causing the signal, but this unexpected event has sparked curiosity around the world.
The signal has to be, in some sense, above the noise level for us to see it. You first of all just try to filter the noise out as much as possible just from a frequency standpoint.
Background of Voyager One. Voyager One was initially part of NASA's Voyager program, along with its twin, Voyager 2. The primary goal of the program was to take advantage of a rare planetary alignment that occurs roughly once every 176 years. This alignment allowed the spacecraft to use a gravity assist technique, where the gravitational pull of one planet propels the spacecraft toward the next, conserving fuel and extending its journey. The original objectives focused on studying Jupiter and Saturn. At Jupiter, Voyager 1 provided the first detailed images of its atmosphere, revealing complex weather systems, including the famous Great Red Spot. It also captured stunning views of the planet's moons, such as Io, which was discovered to have active volcanoes, the first known outside Earth. For Saturn, Voyager 1 discovered the structure of its rings and sent back data about Titan, Saturn's largest moon. Titan's thick atmosphere, rich in nitrogen, was so fascinating to scientists because it resembled early Earth's conditions. But that's not all. After completing its primary objectives, Voyager 1 continued on its journey, heading toward the outer reaches of the solar system. Its secondary mission was to study the heliosphere and eventually cross into interstellar space. This is a feat it achieved in 2012, becoming the first human-made object to do so. One of Voyager 1's most iconic contributions to humanity is the Golden Record. This 12-inch gold-plated disc, attached to the spacecraft, contains sounds and images intended to represent the diversity of life and culture on Earth. Curated by a team led by astronomer Carl Sagan, it includes greetings in 55 languages, music from around the world, natural sounds, and encoded images. While it was primarily a symbolic gesture, the Golden Record serves as a time capsule and a message to any extraterrestrial intelligence that might encounter the spacecraft. Despite being in operation for 46 years, Voyager 1 continues to transmit data using its 1970s-era technology. Its nuclear-powered radioisotope thermoelectric generators still provide enough energy for limited operations. The spacecraft regularly sends information about cosmic rays, magnetic fields, and the interstellar plasma environment. These data help researchers understand how our solar system interacts with the broader galaxy. Voyager 1 is currently over 15 billion miles away from Earth, making it the farthest human-made object in existence. At this long distance, signals traveling at the speed of light take over 22 hours to reach Earth and another 22 hours for a response to return. The spacecraft operates under extreme conditions, where temperatures are near absolute zero, and its systems endure the wear and tear of decades-long use. NASA engineers have adapted its operations to conserve power, turning off non-essential systems and using backup components when possible. Last year, Voyager 1 experienced communication issues due to a glitch in its flight data system, but engineers were able to partially resolve the problem by sending corrective commands. Description of the signal. The signal in question arrived as a garbled, indecipherable stream of data from Voyager 1's flight data system. Normally, this system packages science and engineering data before transmitting it back to Earth, but this particular transmission bore no resemblance to the spacecraft's usual format. Engineers described it as resembling a monotone or nonsensical dial tone when decoded into binary. It brought to mind what one would think alien speak looked like. But before jumping to conclusions that the data was proof of aliens, the Voyager 1 team had to exhaust every other possibility. The fact that this odd signal was coming through, even though Voyager 1 had been maintaining communication and responding to commands from mission control, was even weirder. This suggested that while the spacecraft's hardware remained functional, something had interfered with the data processing or transmission. In March this year, after issuing a corrective command, NASA managed to retrieve a partial memory readout from the FDS. The readout revealed a mix of standard instructions and unexpected anomalies, hinting at a deeper issue within the onboard systems. What happened next was the surprising part. Although the signal wasn't immediately alarming, its unpredictability added to its significance. For a spacecraft operating billions of miles from Earth with decades-old technology, any deviation can potentially signal the end of the mission or an entirely new discovery. Voyager 1's transmissions are a useful source of information about the interstellar medium, the environment outside the solar system. The spacecraft's ability to consistently send data has been key to understanding cosmic radiation, magnetic fields, and plasma waves in this unexplored region, and this terrifying signal disrupted that. First, there was the possibility of a hardware failure. which could severely limit Voyager 1's ability to communicate. Second, the signal hinted at an unknown phenomenon, whether related to interstellar space or an issue with the spacecraft itself. Voyager 1's systems are over 4 decades old, operating in a harsh environment billions of miles from Earth. It was possible that the flight data system, responsible for processing and transmitting data, could be experiencing wear and tear. NASA engineers suspect that corrupted software or a degraded component within the FDS may have caused the anomaly, but there's another possibility. With Voyager 1's location in interstellar space, the signal could also have been influenced by external cosmic phenomena. The spacecraft routinely detects plasma waves, a natural occurrence in interstellar space caused by charged particles moving through the plasma. But if the signal were linked to such an event, it would typically have been recognized as part of the spacecraft's regular science data. High-energy cosmic rays or unexpected radiation bursts could potentially interfere with Voyager 1's systems, introducing errors into the data stream. Although the most likely explanations involve mechanical or cosmic factors, the terrifying signal has prompted some to ponder more extraordinary possibilities. Could the signal represent something truly unfamiliar? Perhaps even a sign of an unknown phenomenon in interstellar space? NASA's engineers are continuing their meticulous investigation into the signal. By comparing the anomaly to previous transmissions, they hope to pinpoint whether the issue lies within Voyager 1's systems or was influenced by its environment. The investigation into terrifying signal. When NASA first detected the garbled signal from Voyager 1, the mission team immediately began an extensive investigation to uncover what went wrong. This process ran deep, as troubleshooting a spacecraft operating over 15 billion miles from Earth involves significant challenges. Every step had to be precise, considering the nearly 22-hour delay for a single command to reach the spacecraft and the same time for a response. The first clue came from Voyager 1's telemetry, which showed that the spacecraft's hardware was still operational and its communications system was intact, but the data being sent back was incomprehensible. Engineers traced the issue to the flight data system, as it appeared to be routing data to the wrong locations in memory before transmission, resulting in a garbled signal. This issue was critical, as telemetry data not only informs Earth about the spacecraft's health, but also provides valuable insights into the interstellar environment. If the problem wasn't addressed, it could jeopardize Voyager 1's ability to fulfill its mission. With no possibility of a physical repair, the team relied entirely on remote commands. NASA engineers sent diagnostic queries to retrieve specific snapshots of the spacecraft's memory. By analyzing these memory snapshots, they could determine whether the data corruption was occurring during storage, retrieval, or transmission. The findings confirmed that the FDS was functioning but misrouting telemetry data to an incorrect part of its memory system. This analysis ruled out immediate concerns like a total system failure or a critical hardware breakdown. Instead, it suggested a possible corruption in software commands or damage to memory sectors caused by cosmic radiation, a known risk for spacecraft operating in deep space. After identifying the likely misrouting issue, NASA engineers worked on solutions that wouldn't overburden the spacecraft's limited power and resources. They reprogrammed the FDS to bypass the problematic memory sectors, redirecting data to functional areas. This required precise coding and testing, as even a minor mistake in the command sequence could worsen the situation. But they didn't stop there. They also utilized the spacecraft's redundancy systems. Voyager 1 was designed with backup components for many of its critical systems. Engineers activated these redundancies to ensure that essential functions like data transmission and storage could continue without interruption. Once the immediate problem was addressed, NASA began long-term monitoring of Voyager 1's systems. Regular diagnostic commands are now being sent to track the spacecraft's performance and detect any new anomalies. The team remains vigilant, knowing that Voyager 1's advanced age makes it increasingly susceptible to system failures. This investigation highlighted the challenges of managing a spacecraft that operates so far from Earth. Despite the anomaly, Voyager One continues to send valuable data about outer space, offering insights into regions of space no other spacecraft has explored. What do you think of the terrifying findings on Voyager One?
The arrival of the Oumuamua into our solar system has indeed opened the eyes of many scientists to reality. All over the world, there is an awakening as mankind has become fully aware of the benefits of understanding the universe. But not only that, we are also aware that ignorance has consequences, which no one would like to bear. In the past few decades, so much has been done to plant man's feet on the ground in space exploration. Satellites have been launched and telescopes have been created, alongside rockets with spacecraft going on missions. As this is so much effort being put in, it is easy to think that we are likely prepared for the worst. But this thought had only lasted until Oumuamua tumbled in on us with such speed, shape, and mystery that tells us that we were never prepared for it. But what is Oumuamua? Though no one knew what it was when it first showed up, it soon dawned on scientists what type of objects they were dealing with. It was nothing known to our solar system but an interstellar object. Amazingly, it wasn't discovered by any space telescope, but was caught in sight by Robert Wyrick using the Pan-STARRS-1 telescope in Hawaii on October 19, 2017. It is not strange that this telescope discovered Oumuamua, since the Pan-STARRS-1 is no ordinary telescope. This telescope is equipped with advanced technology, allowing it to scan large portions of the night sky rapidly without having any problems with atmospheric hindrances. When it picked up on Oumuamua, scientists were thrilled and puzzled, as the cosmic wanderer was unlike anything we had seen before. Interestingly, Oumuamua means scout or messenger in Hawaiian, and it lived up to its title. Estimated to be tens of billions of years old, this strange visitor had arrived from outside our solar system, zipping through at an incredible speed of 196,000 miles per hour, 87.3 kilometers per second. Its funny-looking shape and strange trajectory left experts scratching their heads. Was it a comet? An asteroid? Was it an alien spacecraft? Nobody was quite sure. The excitement around Oumuamua's discovery soon spread like wildfire in the scientific community as observatories worldwide joined the hunt, collecting as much data as possible during its brief visit. Before completing its visit, the strange object made an astonishing close approach to the Sun, and yet wasn't sucked in. This caused more questions to arise on what Oumuamua was. After analyzing its trajectory and velocity, scientists concluded that Oumuamua originated from outside our solar system, somewhere in the vicinity of another star. It entered the solar system from above the plane of the planets, swung around the Sun, and then departed on a hyperbolic trajectory which showed that it was headed back into interstellar space. Oumuamua's visit to the solar system was brief, and it moved too quickly to be captured by the Sun's gravity. It made its closest approach to the Sun, perihelion, on September 9, 2017, and then sped away from the solar system. Indeed, the object's peculiar characteristics and unexpected origin has puzzled astronomers ever since. But what characteristics of the Oumuamua leave scientists puzzled? When encountering Oumuamua, the first noteworthy thing is its strange and abnormal hue and shape, different from anything known in our spherical solar system. For the citizens of the Milky Way solar system, it is usual to encounter space objects that are spherical in shape. This is a result of gravity pulling in from various planets within. But the Oumuamua's shape is nothing like that of objects born within this solar system. But how did it look exactly? Based on its brightness variations, Oumuamua seemed to have an elongated and irregularly shaped structure, which is described to be that of a cigar or a pancake, with a length-to-width ratio of about 6:1. This is the very beginning of its uniqueness, as many other mysterious features of the Oumuamua lies underway. So many speculations have erupted already from the mysterious shape of Oumuamua. According to some, it may have been a product of some sort of collision in space, or might be debris from the early stages of the formation of a new planet. With their unique look, the cosmic needle-like objects still had many things that made them very mysterious. Most interestingly, Oumuamua is said to have a single-like shape and a reddish tint, making it a complete space cigar indeed. There are a few theories why Oumuamua might have a red tint. One possibility is that it is made of a carbonaceous material, such as a comet nucleus. Another possibility is that Oumuamua is covered in organic molecules, which can also have a red tint. However, it's also possible that the red tint of Oumuamua is due to something else entirely. For example, it has been suggested that the red tint could be caused by radiation damage from the interstellar medium. In addition to its weird shape attributes, Oumuamua, when sighted, did not move normally, but was rather found to be tumbling through space. This was quite unusual compared to other moving space objects, and scientists tried to explain this in different ways. Some have developed ideas of a binary system, where two objects are found orbiting around each other. To create a tumbling effect, one of these orbiting objects had likely pulled away forcefully from its companion, causing it to tumble through space and into our solar system. Now, the weirdness of Oumuamua continues, as scientists also observed that Oumuamua exhibited a non-gravitational acceleration. After analyzing its trajectory, researchers noticed that it deviated slightly from what would be expected based solely on the gravitational forces exerted by the Sun and the planets. This change in its speed, as well as its deviation from the course of gravity, is known as a non-gravitational acceleration. Now, when objects like Oumuamua pass through the solar system, their motion is influenced by the Sun and the planet's gravitational pull. Because of this, astronomers can predict their trajectories based on these gravitational forces, and the object should follow predictable paths. However, in the case of Oumuamua, astronomers noticed that its motion deviated slightly from what was expected based upon gravitational forces alone. This deviation suggested the presence of an additional force, hence the term non-gravitational acceleration. The leading explanation for this non-gravitational acceleration was related to outgassing. Here, it is said that Oumuamua approached the Sun. Its surface would have been heated by solar radiation. This heating could cause ice and volatile compounds on its surface to vaporize and turn into gas, which would then be expelled from the object. As gas was ejected in one direction, it acted as a tiny rocket engine, providing a slight thrust in the opposite direction. This thrust resulted in a slight acceleration of Oumuamua, causing the observed deviation from the purely gravitational trajectory. Imagine it like a comet. When a comet gets close to the Sun, the solar heat causes the icy nucleus to vaporize, and the expelled gas and dust create a glowing coma and a tail. Similarly, Oumuamua, although not a comet, could have experienced a mild version of this process, leading to the observed non-gravitational acceleration. While the nature and source of Oumuamua's non-gravitational acceleration may still not be definitively determined, the outgassing hypothesis was one of the most plausible explanations based on the available data. Also drawing attention to the strange Oumuamua was its reflectivity, also known as its albedo, which was known to be quite low. This means that it did not reflect much light. To the amazement of scientists, Oumuamua reflected only 5 to 10% of the light that hit it. This is outstandingly low compared to other space objects' usual reflectivity. As astronomers observed, it exhibited an unusual faint and variable brightness. This characteristic made studying challenging, as its brightness changed rapidly as it tumbled through space. The exact reason for its low reflectivity is not definitely known, but a few possible explanations exist. One possibility is that Oumuamua's surface was made of dark, carbon-rich materials. These materials absorb more light and reflect less, producing a low albedo. Another hypothesis is that Oumuamua could have a thin coating of volatile ice on its surface. As it approached the Sun during its journey, these ices might have sublimated, creating a temporary atmosphere, coma, that obscured the object's true surface characteristics. Prolonged exposure to cosmic rays and solar wind in interstellar space could have caused space weathering on its surface. This process could have darkened the surface, resulting in low reflectivity. The irregular and tumbling motion of Oumuamua might have exposed different areas of its surface to our telescopes at different times, leading to variations in observed brightness. Despite the low reflectivity and the mystery surrounding its exact nature, astronomers could only study Oumuamua briefly before it left our solar system. However, its peculiar properties and limited observation time have led to ongoing debates and discussions about its origin and nature among the scientific community. Among all these numerous debates are the question of what exactly Oumuamua is. Let us look at the first heated debate that arose about the Oumuamua. Is it a comet or an asteroid? While it had been established as an interstellar object, scientists still found it difficult to place their hands on exactly what the Oumuamua was. To answer this question, scientists have come up with so many speculations. Among these speculations was the debate about the Oumuamua either being a comet or an asteroid. This confusing debate has led scientists to closely consider the ready facts. Now, is Oumuamua a comet or an asteroid? Actually, we cannot have the answers if we don't understand what these items are. Comets are icy bodies that develop tails as they approach the sun. This tail is known as a coma, a visible cloud of dust and gas that surrounds the comet's nucleus as they approach the sun. This coma is formed due to the sublimation of volatile materials from the comet's surface. Now, this is what majorly differentiates the Oumuamua from a comet. No visible coma was observed despite its proximity to the Sun during its passage through the solar system. As for asteroids, they are mainly rocky objects. According to scientists, Oumuamua is also not an asteroid, and here is why. First, the shape of Oumuamua sets it apart from most known asteroids. This is because its elongated cigar-like shape differs from the more common irregular shapes or rounder appearances of asteroids. Another difference is that asteroids are gravity-bound, while the Oumuamua is not. But if Oumuamua is neither a comet nor an asteroid, what is it? In the end, the confusion about the Oumuamua not being an asteroid or a comet has made some scientists speculate about the possibility of it being an artificial object, such as a probe sent by an extraterrestrial civilization. Avi Loeb, an astrophysicist at Harvard University, is the most prominent proponent of this theory. Loeb and his colleagues have argued that Oumuamua's unusual shape, high speed and acceleration could all be explained if it was a light sail, a type of spacecraft propelled by sunlight. Other scientists who support the alien probe theory include Shmuel Avatel, an astronomer from the Weizmann Institute of Science in Israel, and Alberto Caballero, an astrophysicist at the University of Vigo in Spain. However, most scientists have remained skeptical of the alien probe theory. These scientists have all pointed to the unusual properties of the Oumuamua, such as its elongated shape, high speed and acceleration, as evidence that it is not a natural object. They have also argued that the alien probe theory best explains these properties. In the end, the scientists opposing this notion argue that there are more mundane explanations for Oumuamua's properties, such as the possibility that it is a comet stripped of its volatiles or a natural asteroid elongated by its rotation. So what next? Even though the speed of the Oumuamua makes it unique, it might not be such a good thing for us, as it implies that the Oumuamua might be slipping off the observing eyes of scientists even before there is a chance to understand what it really is. The reality of this has created concerns among scientists, currently doing all they can to gather as much information as possible from the Oumuamua before it finally disappears into the cosmos. One thing that has been instrumental to the information currently being gathered from the Oumuamua is the James Webb Space Telescope. Indeed, the Oumuamua had first been sighted by the Pan-STARRS 1. The James Webb Space Telescope soon took over, proving crucial to the study of the Oumuamua by capturing its precise and clear images. In case you didn't know, the James Webb Space Telescope, JWST, is a space-based observatory and the successor to the Hubble Space Telescope. It was named after James E. Webb, a former NASA administrator, being a joint project between NASA, the European Space Agency ESA, and the Canadian Space Agency CSA. where it was launched on December 25, 2021. The abilities of this telescope will astonish you. First, the telescope is equipped with advanced technology, including a 6.5-meter diameter primary mirror, making it the largest space telescope ever built. Its main advantage is its ability to observe the infrared spectrum, allowing it to see through dust clouds and observe visible light. These features enable JWST to study the formation of stars, galaxies, and planets, even in the early universe. The primary scientific objectives of the JWST are to study the first galaxies formed in the early universe, observe the formation of stars and planetary systems, investigate the properties of planetary atmospheres, including exoplanets, and study galaxy evolution and supermassive black holes. For this, the JWST has been positioned at the second Lagrange point, L2, around 1.5 million kilometers, about 932,000 miles from Earth. This location allows it to maintain a relatively stable position concerning the Earth and the Sun. After its launch, the JWST underwent a series of complex deployment procedures, including unfolded its sun shield and aligning its mirrors and instruments. It took several weeks for the telescope to become fully operational and is designed to function for at least 10 years. With its infrared capabilities and sophisticated instruments, JWST has revolutionized our understanding of the universe.
Share your thoughts with us in the comment section. Remember to like, share, and subscribe for more. Also, click the next video showing on your screen. You will enjoy it.